Most websites primarily deal with user input such as personal information, search queries, or information about items they want to register. However, occasionally, there are situations where you need to input something unusual. One example is uploading image or photo files when registering an item. While it's well documented in the File Upload Attack section, uploading just one image file can have significant repercussions. It might appear to be just an image file, but it could contain malicious code inside. Now, have you ever encountered a place where you input Linux commands or file names? It's not very common, but it's not something you can rule out entirely. This is particularly prevalent in places like admin pages, but fortunately, those usually require admin login, so the risk isn't significant. However, in admin pages, there's often a need to input Linux commands for system management purposes. These commands, like ping, find, ifconfig, root, netstat, ps, ls, etc., are entered via a web interface, which then passes them to the web server using back-end programming languages like PHP, JSP, or Python. Usually, functions like exec are used for this purpose. It's relatively easy to create functions that allow users to input network management commands and display the results on a web page. Sometimes, these functions are even available to regular users, not just administrators. Of course, it's not like users can input entire commands. They usually only input the information needed for the command. However, instead of users directly inputting Linux commands, it's generally better to create a button that handles everything internally. But there might be situations where more advanced functionality is required. For commands like ping c5 www.badhackers.com, you can simply allow the user to input www.badhackers.com without letting them manipulate the number of packets to send. This makes it seem less risky, but it's also the beginning of potential issues. Now, you might wonder what harm could be done in such places apart from entering URLs. If it's just following orders, then it's expected. However, if there's an option to perform tasks other than the original task, the situation changes. Operating systems have symbols used for sequential tasks in console operations like semicolons, ampersands, pipe symbols, etc. In Linux, for instance, a semicolon ensures that the second task is executed after the first one, regardless of success. An ampersand means the second task is executed only if the first one is successful. A pipe symbol means the first task's output is passed to the second task. In essence, these symbols act as joints, connecting multiple commands. Exploiting this is what's known as command injection. Now let's see if these things are actually possible and discuss how to filter them. When you click on the Find Image link on the homepage, you'll see a place to search for files. Here, you can browse through the picture files uploaded to the web server. Let's see if there's a picture file named BFG9000. If the file exists, it'll show up like this. Now let's input a non-existent file and see what happens. Nothing comes up at all. But what if we insert a semicolon after the picture file and add another command? See that? The ls command runs, showing all the files in the current location of the web page. Let's find out the actual location of the current web page this time. It's a directory called itembox under www. Now let's extract all the information of all users stored on the web server this time. There you go, all the information of every user on the web server has been leaked. In fact, doing this allows you to even view the source code of the web server. If you look closely, you can see leaked PHP codes. Analyzing these might reveal more vulnerabilities. What happens if we do this? The nc command will execute the shell and attempt to connect to the hacker's server outside. Now, on the hacker's end, they just need to keep this port open and wait. And now, executing this will establish a connection to the hacker's side. Looks like the connection is established. Now, we can also list the files with the ls command. Just like before, we can also explore the source code of the website. We can also gather network information of the server. Let's see how defense works this time. We'll switch to a page with security applied. Let's check if the setting to the secure version of the search image page is done correctly. Let's try the same attack method as before and see if it works this time. Nothing comes up again, seems like it's filtered. Let's try this. Still nothing visible. How about this? Similar to semicolon or ampersand, but this one is designed to execute the second command only if the first one fails. Same result, no effect at all. Here's the filtering code. See line 7? It's where ampersands, pipes, semicolons, etc. are filtered out. If any of these are input, they're replaced with blank space. But if something else is input, the attack will work. So, the safest way to go about it is to block everything and only accept pure file names. Got the gist? It's about sneaking in some funny business after the original task ping c5 www.badhacker.com by inserting symbols like semicolons, allowing for some clandestine mischief. To defend against this, obviously, we need to filter out those strange symbols, but adding them to a blacklist might clutter up the code. Sure, we could use regular expressions, but they can only block what's known so far. So, to really prevent such shenanigans, we'd either have to whitelist only the things we need to pass through or strictly allow only alphabets. Or just numbers, for that matter.